In this video, we're going to be covering coterminal angles and length of a circular arc. So the first thing I'll start with is let's draw a circle down on our XY coordinate system. I'd like to first just define the quadrants. We have 4 parts here that are broken up into quarters, so there are 4 quadrants. We usually define quadrant 1 as the place that the x is positive and the y is positive. We have quadrant 2 in the top left, so x is negative, y is positive. We have quadrant 3 in the bottom left, so both x and y are negative. And we have quadrant 4 down in the bottom right, and so x is positive, y is negative. And this makes sense based on the information in the last video where we started with our initial side here, and we rotated the terminal side in this direction. So we first run into this quadrant, and then this one, and then the third, and then the fourth. I'd like to write down a definition now. Definition of coterminal angles. Two angles are coterminal if they have the same terminal side. So let's do an example where we'll see what's happening. Example 3 here is find coterminal angles for, and then we have a few parts. Let's do 750 degrees first. I'm going to work this out without a picture, and then I'll draw the picture to help explain what's going on afterwards. So, two angles are coterminal if they have the same terminal side. Well, since going all the way around the circle is 360 degrees, then if we subtract 360 degrees, we get angles that are coterminal. So what is this? This is equal to 390 degrees. Then if we take 390 degrees and we subtract 360 again, then we get 30 degrees. So these two angles are coterminal. Let's draw a picture to make sure we understand what's happening. So we have our circle. Angle 0 is here. Angle 90 is straight up along the positive y-axis. So whereas 30 is 1/3 of that angle, so it is there. But notice if we start here and we go 360 degrees, so all the way around the circle from that point, we end up back at that same spot, which would be 390 degrees. Right? We start with the 30 and then add 360 to that. We could add 360 again to get to our 750 that we started with. And so all of these angles are coterminal. I could have also subtracted 360 again and noticed that negative 330 degrees is coterminal as well. Okay, now that we understand the basic idea, let's do 2 more quick examples related to that. So part B is going to be 16 pi over 3. Now here we're dealing with radians, So instead of subtracting 360 degrees, we should subtract 2 pi. So 16 pi over 3 minus 2 pi, well, that's equivalent to 16 pi over 3 minus 6 pi over 3. And this is equal to 10 pi over 3. So then we start with 10 pi over 3, and we need to subtract off 2 pi again. Well, 2 pi is 6 pi over 3. So we get 4 pi over 3. And now we end up with a value between 0 and 2 pi. Now, this is also a coterminal angle, and in the question I just asked to find a coterminal angle. So really, you could have written any of these values as coterminal angles, either 4 pi over 3 or 10 pi over 3, or if we keep going, negative 2 pi over 3. But most of the questions on MyMathLab will ask you to find an angle between 0 and 2 pi. Or if we'd asked about degrees, then between 0 and 360 degrees. So be aware of that. It's a little different than how I asked the question here. Let's do one more example, and that is negative 5 pi over 3. Instead of subtracting 2 pi, now we should add 2 pi if we're trying to get something between 0 and 2 pi. So let's add 2 pi. And we get positive pi over 3, and that is between 0 and 2 pi. Okay. There's just one more type of example to cover today. And let's discuss length of a circular arc. Let R be the radius of a circle. And theta be the radian measure. It is important that you measure this angle in radians. The radian measure of the central angle of the circle. Then the length of the intercepted arc is, and then we will draw the picture. What do I mean? We have some R here, theta here. We're going to call this length S. And what is that? That is the length of the line here that's going around the arc. And what is our value? Well, S is equal to R times theta. Again, it's very important for this formula that theta is in radians. So if it's in degrees, then S is equal to R times theta times, well, we need to convert this to radians. How do we convert that to radians? Well, we multiply by pi and we divide by 180. And so this is the formula if theta, let's call this theta 1 to mark it differently from here. If theta 1 is in degrees. Okay. So here's our formula if theta is in radians. So if this central angle here is in radians. If it's given in degrees, then we need to also multiply by pi over 180. Now that we see that, let's do an example. This should be example 4. So what if we said, suppose two towns have the same longitudinal degree, one town, sorry, has a latitude of 21 degrees and north of the equator, and the other town is 48 degrees. So I'll write it out, both north of the equator. Assuming the radius of Earth is 4,000 miles, how far apart are these towns? First, we need to assume something, and that's that the Earth is a perfect sphere. That's not actually true. The poles along the North and South poles are a little more pushed in towards the center of the Earth than the equator is. The Earth does bulge a little bit at the equator, not by much. So this is still a fairly accurate assumption. So let's go ahead and assume the Earth is spherical. And if we make a cross-sectional cut on the Earth at that longitudinal degree, because these towns have the same longitudinal degree, then one of the towns is at 21 degrees. Another town is at 49 degrees. So the angle between the two is 28 degrees. And if the angle between the two is 28 degrees and the radius is 4,000 miles, then we can calculate the angle, or the length here. And that is S is equal to R times theta, but we gave theta in degrees, so we need to multiply by pi over 180. So we plug this in. R is 4,000 times theta, which is 28 degrees, times pi over 180. This is 4,000 times 14 over 90 if we reduce, times pi. And then I don't have a calculator with me, so plug that into your calculator to find a decimal value. But we should get the length between, or the distance between the two cities by plugging that into our calculator. And that'll do it for the end of this video.